Hello ladies and gentlemen, in this video you're going to learn some more tips and tricks for graphing absolute value equations. This comes after you know how to graph your basic absolute value function with the slope of 1 and -1 and the vertex at the origin. As a reminder, here's your basic family of functions here and how it shifts your absolute value graph. If your graph is going to vary from your regular absolute value graph, let's say here is your normal, just y equals absolute value of x. If that graph is going to shift to the right, we're going to have x minus a number. If it is going to shift to the left, it's going to be x plus a number, and that's going to be inside the absolute value. If it's going to go up, you're going to have plus a number outside the absolute value, and down would be subtracting a number outside the absolute value. If you don't have these memorized, I suggest that you go ahead and write them down now, because they'll be very helpful for you as you graph these kind of equations on your own. So go ahead and pause and resume when finished. Something that you haven't learned yet is when the absolute value graph is squished, I'm going to say. This is when you have a number times x. Whether that number is inside or outside of the absolute value, it's going to change the steepness of the sides of that absolute value graph, just like it would if you had the slope. So let's go ahead and view an example of this. Here is the graph of y equals the absolute value of x. If it was y equals 1/2 the absolute value of x, or maybe your 1/2 is inside the absolute value, it wouldn't matter. It would be the same graph. The vertex would stay the same. We're going to go up 1 over 2, because that is our slope, up 1 over 2. And then in the opposite direction, we're going to go up 1 back 2, because absolute value always stays positive unless we've got a number over here minus a number telling us it needs to be shifted down. But there was no shifting here, it's just multiplying by a number. Okay, so we can see how our sides of our graph have taken on the slope here, just as if it wasn't written as y equals mx plus b. Here's another graph. Let's say we want y equals 3 times the absolute value of x. Vertex stays the same. I'm going to go up 3 over 1, up 3 over 1. And I'm going to go up 3 back 1, up 3 back 1, doing my best to keep this drawing accurate. So you can see, just like slope, the bigger the number, the steeper the slope. So each side of your absolute value takes on the slope, or the negative version of the slope. For this side, that's the negative version of the slope, in order to properly graph that. Let's look at one more way an absolute value graph might be manipulated. Here we go. It might be flipped upside down. So instead of your graph looking like a V, it may look like an upside down V. The way that it would look like an upside down V is if there's a negative outside of your absolute value. Because absolute value is always positive, if you put a negative in front of a positive, that is going to be negative overall. And so all of our y values then would be below the x-axis. Of course, unless we shifted it up somehow. But if it's just your basic absolute value equation that is negative, okay, it will flip. So before we get into graphing, just a problem on our own, let's go over these steps. First, you're going to start with your y equals the absolute value of x, your basic function. Then you're going to look for clues in how your equation is written. Does it go up or down, left or right? Is it flipped? Is it squished? Then you're going to find the vertex. Not always, but the vertex is usually the opposite of the constant that is inside the absolute value symbols, because that is the number that tells us left or right. Then you're going to make a table and plot points until you have the vertex and a point on each side of it. And once you have that, let's say you've got something like this, okay, you're going to just go ahead and graph your absolute value. So let's go ahead and try an example. You might see an equation that looks like this bottom one that you're asked to graph. There's a lot there. It's important to break it down into these earlier steps that are a little bit easier to graph. And we're just going to keep building. We're going to go from this equation to this one to this one, and we're going to see how each of those changes our graph. So let me pull up some graph paper here and we'll get started. Okay, so we are always going to start graphing absolute value equations by thinking of our parent function, just y equals the absolute value of x. And so that's there in green. The first one we were asked to graph on the last slide is y equals the absolute value of x minus 4. Remember, this minus 4 tells us that we're actually going to shift this vertex to the right 4. So I have 1, 2, 3, 4. There it is. So that is our new vertex. It has been shifted to the right 4. And our slope hasn't changed. It's still up 1 over 1, or up 1 back 1. So there is the graph of the absolute value of x minus 4. We're now going to get a little bit more complicated. And the next one we were asked to graph is y equals the absolute value of x minus 4 plus 1. So we're going to take this purple graph, and remember that this plus 1 here means we're going to shift the graph up 1. So our vertex is going to move up here. From there, we're going to go up 1 over 1, and up 1, back 1. And again, I'm doing my best to keep this accurate without having the grid lines. Okay, and we were asked to graph one more. And so we're going to go ahead and graph in this example, our vertex does not change. I said that the vertex is typically the opposite of the number here. So your vertex is going to be along the negative 4. I'm sorry, not negative 4, positive 4. It's the opposite. Along the positive 4 line for x there. Okay. And let's see what that looks like if we put it in a table, because this is going to be complicated. I want to make sure we're doing this correctly. So if x is 4, let's see what y is. We have 1/2 times 4 minus 4 plus 1. That's going to give you 2 minus 4 is 2, 2 plus 1 is 3. So the point 4, 3 is on our graph. So it may be shifting, actually. Let's see. And since this is a really complicated equation, we're going to try another value. And we're going to see where that would fit in. Let's try 8. If it was 8, I would have absolute value of 1/2 times 8, which gives me 4. 4 minus 4 is 0, so 0 plus 1 is 1. So the point 8, 1, so this would be 5, 6, 7, 8. 8, 1 fits here. Okay, let's try another value. Let's try higher than that to see if it's going to go up or not, because right now I've got this. Let's try 10. 1/2 times 10 minus 4. 1/2 of 10 is 5. 5 minus 4 is 1, and 1 plus 1 is 2. So here it starts to go back up again. So at 10, the y value is 2, and I'm going to overlap my green writing a little bit. Let me make sure this doesn't go down anymore, because it could be like that, and really, I guess, in between the other 2 points, it could have gone down at some point. So we need to try another point here. Let's move our table here. Let's try 6, because I've got 1/2, so taking half of an even number is easier. So 1/2 times 6 is 3. 3 minus 4 is -1. The absolute value of that is 1. 1 plus 1 is 2. So 6, 2 is another point. So it is there. And it looks like it's coming right back up because my slope is 1/2, remember. So I've got up 1, back 2 for this side, up 1 over 2 for the other side. And so here we have used our graph and our table, making sure we have those 3 points, the vertex and the other points, one on each side, to go ahead and graph our absolute value. So for complicated equations, you'll want to try the table of values. For ones that are not as complicated, these ones up here, when we took it step by step, we were able to graph them without the table. So you make the choice based on how complicated the problem is for you. It's always a good idea to check with a table of values, just to make sure that you are graphing them correctly. For our last example here, I want to show you what happens when there's a negative in front of the absolute value. So, excuse me, the purple, we're going to graph just the absolute value of x minus 2, remembering that that minus 2 makes us shift 2 to the right from the origin there. So our slope is 1 because there's nothing in front of the x. So we're going to go 1 and a slope of -1. And there is the graph of the absolute value of x minus 2. Now when there's a negative in front of that, it just flips it. So it's going to keep the same vertex and it's going to flip down over the x-axis. And so it's just going to become actually a reflection, and because our graph wasn't shifted up off of the x-axis, it's a reflection over the x-axis. So when you have a negative in front of the absolute value, you're going to graph whatever was in the absolute value, and then you're just going to reflect it down because of that negative sign. Go ahead and try this on your own. Remember to take it step by step. So start out with the simple y equals the absolute value of x, and then what happens when you add 4, what happens when you subtract 1 from that, and then finally go ahead and change the steepness of your sides because it should have a slope of 3. Good luck.